Alright, so I think I'm recording. I have to do this problem over a second time because the first time I posted my solution, I'm pretty sure there was an error in it. So let's see if I can do it right this second time. I notice that here that it is in standard form, but there's a greatest common factor of x squared. So I need to factor this expression, x squared, and then I'd have x to the fifth, x to the fourth, minus 2x to the third, minus 2x squared, plus x, plus 1. So when I apply my rational zero theorem, which I often call the rational root theorem, I look at my factors of my constant term. Oh, let's go. That was printed out on the worksheet. Oh, that's fine. I'm talking to myself making video, so I hope that doesn't bother him. I just had a couple students come in. All right, so factors of the constant term are plus and minus 1. Factors of the leading coefficient are also plus or minus 1. So the possible list of zeros is just positive 1 and negative 1. So let's come over and you could plug in 1 or negative 1. I'm just going to do synthetic division. And if I find a zero remainder, then I know that this is an x-intercept. So I do get a zero. And I think last time I had a mistake that I did not get a zero. So I know that x equals 1 is an actual zero to this. But now what remains is a fourth degree equation. And now it's possible that this x equals 1, this x-intercept, remember that we have multiplicities sometimes that are greater than 1. It's possible that this could be a repeated root, a repeated solution. So let's go ahead and check that real quick. We're not using the zero any further. Let's pull a 1 down. And it does. It is a repeated solution. So we normally don't list it more than once. Now, let's see, it was a fifth, so this was a fourth, this is a third degree. Could be repeated again. Let's look and see if it is. And it's not. I'm not getting a zero right here. So let's try negative 1. Because remember, I started with a fifth degree, so this one's a fourth degree, this one's a third degree, and if this one does have a zero remainder, well, I'll have a second degree. And it is a zero. All right, now I can see the numbers right here. This negative 1 repeats again. Now, I could write this as 1x squared plus 2x plus 1, and I can see that's a perfect square, x plus 1 quantity squared. That's how I'm able to recognize that negative 1 is going to be an x-intercept. We do get a remainder of 0. Now remember that we're not using the 0. We're just using the 1x squared plus 2x plus 1. And we have a 0. So we can now write, using all these synthetic divisions in this final one, we can write, we can factor this f of x, totally factor it. We knew initially that we saw an x squared that was factored out. And then we started doing synthetic division on this x to the 5th, and our first two synthetic divisions showed us that x was equal to 1, and in factored form that's x minus 1. And then the next two told us that negative 1 was an x-intercept. In factored form that's written as x plus 1, and there was two of those. But then remember the 1, 1 right here, that's x plus 1, so that's another x plus 1, so we would write it instead of that, we would write that to the third power. Alright, so let's shrink this up and put these answers in the form of a table. Oh, I also left out x equals 0, my initial factor here. So in my table, I have 3 zeros. I have x equals 0, x equals 1, and x equals negative 1. The multiplicity of each of these, at 0 it's 2, 1 minus 1, there the exponent is 2, here the exponent is 3. These are even numbers. And this is an odd number. How are we intersecting the x-axis? Well, it's always going to intersect the x-axis as a cross or as a touch and turn. When you have an even multiplicity, it's a touch and turn. When you have an odd multiplicity, it's a cross. And if the video that I had over the weekend was incorrect, I apologize for that, but this should be the correct answer now. Hope that helps. Talk to you later.